Right, next I'm going to use this. This is a centre drill, and it's pretty much descriptive of what it is. This little tip is about 2.5 millimeters, and this is a 2.5 millimeter normal drill. And you can see, well, you can sort of guess that's going to be very, very flimsy, and it flexes a lot if you don't drill a pilot hole for it. Because it'll bend, it sticks out the drill too far. So what you need is a big fat thing like this with all the strength is in the body, and then just a little tip to make the pilot hole. And it also countersinks the hole as well, so you've got a nice dish in the top for centering. And I'll show you how it works. So now I've put the drill chuck in there instead of the centre, and I've mounted the centre drill in there. So now we're going to just drill the middle of that block. Just stopped it there to lubricate it because that little tip, that's 2.5 millimeters, it can get very, very hot quite quickly, and if you're not careful you can damage it. There we go. Now remember, we've made a hole in there, and that centre drill is going to be a nice snug fit back in that hole, and we're going to use it on the next operation. So next, the milling drilling machine. Look at it. Now what's going on here then? You recognise this, we've just done that with the centre drill hole in the middle. What about this then? This bit of kit is my rotary table, which is pretty obvious. It's a table and it's rotary. You spotted that, didn't you? This isn't the same chuck, by the way. This is a different chuck, but it is self-centering. But we've got this added bonus on here, down here, down here, down here. You see that says 0. And if I turn this handle here, round she goes. Or let's do it that way and go upwards. Look. 10 degrees. 20 degrees. Look at that. Hey. Who would have thought? Anyway, so we put it back to 0. So, yeah, we're all about centres again, aren't we? So we need the centre line here, down through there. At the minute, this is free to move all over the place, but I can bolt it down with these slots. But what we've got to do is to centre it on here first. So the procedure is we centre it, and then we move it 17.75 millimeters one way, either that way or that way, don't matter. And then we drill the first hole, and then we move it 8 holes, 360 degrees. We move it 45 degrees, and then drill another hole, and then just keep going until we've got 8 equi-spaced holes. So let's do it. Right, so here we go. Now in here I have got the very same centre drill that we just used on the lathe to make this hole. And remember I said it'd be a snug fit in there? Well, it's going to be a snug fit in there again, because I'm going to wind this down and line it up in the same hole. And then if I wiggle it like that, it can't go anywhere like that. There you go. Now that is centered, because it can't go anywhere. It's gone straight in the same hole. Now I just need to adjust the table. Hang on, I'll show you. There you go. Oh, let me adjust the camera. Right, I'm adjusting the table so that these slots line up so I can bolt the thing down. Because I need to We've got two keys here which will lock the table in position. So that's it. That's it centered. Right. So we've got to move it 17.75. Except that some div tightened these up, didn't he, before he moved it. So it ain't going to go anywhere till they're undone. Right, which way should we go? That way? Yeah, go on then. 17.75. See when. Woo. I've got to come up to it slowly because I don't want to go past it because of the what they call the backlash in the gearing. You have to come back, it won't be accurate. So I've got to get up to it. 7.5. 7.5. Whoop. 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 Whee. So lock them off. Oh. 7.6, you little devil. Well, do you know what? I'm not moving it. Not for 0.01 of a millimeter. We're not making aeroplanes, we're just making steam engines, and that'll do. So what I've got to do now is zero me doodad. Right, this one. There you go. So that's 0. It's time to move it, move it. Right, 45. You'll have to trust me on this. Of course, I should explain that we are just drilling pilot holes with this, so that when we put a 3mm drill in, they'll go down the same hole quite accurately. 90 then. Well, 1, 2, 3, 4, 5, 6, 7. Well, there's 8 of them. So now I've put in the 3mm drill, and I'm going to be using this DRO, digital readout, to measure the depth. I'll probably drill the hole about 4mm because we need this 3. So if I drill down 4mm, we should be fine. Right, before I carry on with that, it would be sensible, as if we're going to do something sensible for a change, to remove this rim and get this ready to fit, so we can machine that and try and fit this in it as we machine it. Get in focus. There you go. Right. Problem is, this is a copper tube with this end soldered into it, look. and this is soldered. Now what we've got to do is warm this end up to unsolder this, get in focus. That's annoying. There you go. We've got to warm this end up to get this solder off and get this rim off, but not get it too hot that this solder melts and the whole thing falls to bits. So we just got to be careful. It's doable, but we just got to be careful and be aware of that problem. So first of all, actually, I said I might be able to pull it off. Hang on for a start. There's a bit. Look. There you go. There's the first bit. Focus. There you go. There's the first bit gone. So right, let's get the rest of it off. 6 degrees in here, and that's rising because I've got the heaters on and the artillery out. Look at this. Brr. Right, got my gloves on, look, because it's cold. First thing I'm going to do is put these on the vise. They're just bits of aluminium that I've folded, and it's a standard thing that they do in the workshop, and they're called soft jaws, and it's for holding soft metal, because otherwise you can damage soft metal like copper, marks easily. So we use soft jaws. Right, so if I put this in here like this. Now another reason is, the reason I'm holding it in there is because, like I said about the heat travelling along the tube, there's a mass in this vise. It's a lump of metal, and so when I heat this, some of the heat will go into the vise itself and not get to there. Well, that's the theory anyway. Keep watching, I might make a right mess of it. Well, that was a fail, so I've broken it off with a pair of pliers as best I can. Now I'm going to turn it up in the lathe. There you go. I finished boring this inside out. I haven't filmed it because I've had a bit of trouble with the equipment. So anyway, here's the thing. Look, I've cleaned it up and it fits in there. It's not a tight fit, but that doesn't matter because we're going to solder it, and the solder will take up the gap. So I've just got to part it off, which is a horrible job, and I'm not even going to film that because it's definitely going to go wrong if I do that. Well, there you go. It's done. And it fits in there, look. I'm very disappointed with it because it's not anywhere near perfect. Look, that side's okay because that was the outer part of the turning, but when I parted it off, it's rough. In engineering terms, if you were an apprentice engineer, the old person teaching you how to do it would say, that's as rough as a badger's arse. And I'm not going to do it again because I'm getting a bit disappointed with it. Anyway, the thing is, I've had problems with my lathe. I was thinking it was me and my inexperience, but I think there's a fault with the lathe. So anyway, we've got this far. The next thing I've got to do is to solder that in there. Okay, and I'm hoping that bit's going to work because I'm a bit low on gas in my blow torches. So I might be struggling even with that. So let's get on with that. Right, let's give this a go then. I'm going to try and solder that in there. Now what I've got here is some flux. This is a powder that I've mixed with some water, and wherever I put this, hopefully the solder will flow, and where I don't put it, the solder won't flow, so we don't want it all over the place. So what I've got to do is I want some on the inside of this ring, but not on the back, because I want that surface to be a good seal. So I'm going to carefully put some around here. Whoops. Being very careful. I hope you can see this. You can't see this, can you? Here you go.
I'll do it here then. Right, that's that. And then a spot. Where are you? Around the bottom of here. Like this.
Like that. There. Now, warm it up, and tell you what I need first is some solder. That'd be a good idea, wouldn't it? Well, here we are then. This is how far we've got. We've got. There's been a delay because you can see my lathe's a bit wonky. It's because I found a fault with it. So I've delayed the project on the loco while I rebuild or refurbish the lathe. I've done all the maintenance on it, but that's going to be another video. So I'm halfway through it. But where we are with this steam dome, let's get the steam dome and my hands in focus. There. Right. We've soldered it on, and it was a bit of hassle. Come on with this focus. It don't really matter. You can see it anyway. Yeah, we've got it on. What we had to do, we had a problem with heating it up because we couldn't get enough heat into it. Anyway, what we did was we got this piece of silver solder here, and we made an almost perfect ring around this piece of tube. So we had a ring of silver solder, and then we dropped it down onto there, put that down on a surface like that, and then we put the ring round there, having put flux all around it, put the ring of solder around there. Then we had 2 blow lamps, and we had to get 2 blow lamps to get enough heat in it to melt the solder. It was a lot more than what I was expecting. Domestic solder just is a lot lower melting point. It just takes a couple of minutes. If you like ordinary plumbing solder for domestic pipe work, but this is really high temperature stuff, so we really struggled. Anyway, the next thing I want to do is I want to turn this surface to make it nice and smooth so that it makes a nice steam seal, but also to make it at 90 degrees to this tube, so that it's 90 degrees that way, so that will then sit bolt upright on top of the boiler and not be at an angle. If it's an angle, it might catch that pipe, so we want it to be bolt upright. It's just a piece of... So I'll clean it up there, and I've got to clean it up there, but I can't do that until we've done the lathe. So there's going to be a bit of a delay, which you won't see because this is a video, isn't it? Here we are then, finally finished. I've cleaned it up a bit there and there. Look at that for a nice finish. So that is now perfectly 90 degrees. So all we've got to do now is get some bolts and fit it to the top of the boiler and carry on with the rest of the stuff. So that's done.